Resume recording. Okay. So we are gathering together today to discuss about the exam that you are going to. You'll have 3 days to pass it. So I'll just publish the tasks for you, and you will respond for them in Moodle. So the Moodle will automatically check the results you have. That means that some questions involve several tasks in them, and you have to provide a single number. And you just have to make sure that you won't shrink your number. So you just provide the same number as the RStudio gives you during your calculations. And if you're asked to, like in our first task, so provide an answer, one number, sum of all calculated values. So you have to calculate all the values and then just sum them all together. And please make sure that you sum all of them. Okay. So several questions like this provide a single number. You have to provide a single number for, this is kind of work question, but still I'll explain which probabilities you have to use, which integer numbers you have to use in order to provide this good single number. There might be questions with calculate the mean and the variance, for example. So you calculate two values and then you just provide a number and answer the sum of calculated values. Again, this will be the single number. So just don't forget to calculate both, like expected value and variance, and then sum them all. All right, so here we are going to start. And the first topic I'm going to discuss, this is the insurance distributions. The insurance distributions, this was our first lectures after we actually met after the midterm exam. So we were talking about different types of distributions, like the exponent one, Pareto, Weibull, and so on. So we try to make them look like fat tail distributions to understand what are the probabilities of the large values to appear in this kind of situation. So this is the tasks which you are given, and you have to calculate the tail probabilities that X is large enough, like X more than 5,000, more than 10,000, more than 15,000. So let's try to calculate everything. And one important thing about the Pareto distribution, which is also required to calculate, don't forget to load the package. The package you will need is called the Ectoar, because only this package contains the value which you are required to calculate. So the functions are actually, let it be X, which is 5,000, 10,000, and 15,000. It's quite multiplied. Okay, and make it like that. All right, so this is our X value, and we actually need to calculate the 1 minus probability of exponent distribution, which has the particular parameters inside. So 1 minus p exponent is like that, and then we have to understand what will be the X values. Okay, the px, the px distribution. Once again, I'm just reminding you that there are there are certain values like the large fat tails, the smaller fat tails, so the probability of exponential distribution is not that is not that fat-tailed, but still you are able to use it to calculate the particular values. Is it fat-tailed or not? So what you have to provide? You have to provide the probability, the exact value. So let's try to calculate the x values, and these are the three values for the probabilities that you are going to calculate. So the other thing is the 1 minus gamma. Again, the p gamma, and p gamma we provide the exact values which are given. So 0, 3 zeros, 1, like that. So these are, let's create some variables. So S1, S2, and S3. This is where we actually need the Octo-R package for our calculations. 1 minus P Pareto. You can notice this is going from the Octo-R package. So once again, X 1.4 and 550. Make sure that everything is calculated. Do you see the screen actually? Is everything okay? All right. And where's the chat? This is the chat. Yes, okay. Everything works perfectly. Then the last distribution that we need to calculate as 4, 1 minus p variable. Once again, x values and 0.4 1000. These are the what we actually calculated. We have calculated the probability that the exponential distribution with this particular parameter will be larger than this kind of values. So x is just 3 values, so we have calculated them. And let us use the sum in front of all those distributions. Place the summation signs. Okay. Here we are. Recalculate S1, S2, S3, and S4, and the result will be the sum of S2, S3, and S4. Okay, so we have to provide this single value. So just copy the value that you see, copy and paste inside the Moodle to check the result. So this is it for task 1. We have provided one number, sum of all calculated values for our particular for our particular task. Okay, any questions here? Okay, if everything is all right for you, then we move on to our problem 2. Okay, and problem 2 requires us to calculate the distributions for claim sizes. So this is our distribution. Find the mean and standard deviation of the distribution and evaluate some tail probabilities. Provide a single number. So this is actual distribution which are used to calculate the claim sizes, how many claims there will be for our policies. And actually we obtain all the information, we need to calculate the mean and the variance of the distribution. So just we need first to specify correctly the parameters. That's two. The parameters will be mu and sigma. Mu is 0.75 and sigma is 0.2. Then we find our expected value. Again, you can open the slides for this particular distribution where I have specified the mean and the variance, or you open the Wikipedia, place the log normal distribution there, and there will be on the right-hand side the small version of what are the values for this distribution are. And or just use this kind of formula. The E is the exponent of mu plus 0.5 times sigma squared. This is the expected value, and the variance of the distribution, the standard deviation, I would say. Standard deviation is 1 minus. It is just E times expected exponent of sigma squared minus 1. Okay. And because this is not the variance, we just take the square root of it. So exponent sigma squared minus 1 on the square root. Okay, so ES, what is the value of S? S is 0.43. Sigma squared minus 1. Exponent of sigma squared minus 1. And this is that. Okay. All right, so then we try to provide something like what will be the probability 1 minus PL norm. We're talking about log normal distribution, and then we place some kind of numbers. So let's place 1 with our parameters mu and sigma, and we have this large probability. Our goal is to find out the integer number, which is about 0.005, which is about 5%. Look for about 5%. So the values will drop rapidly. So second value is 0.61. The third value is already 0.04. So this value is really close to what we need, and approximately we check what will be. This is farther from the 0.05 than 3. So this will be our denominator, and our numerator should be the value which is 1 point larger than the value that we have found. Okay, so this value gives us 0.04, which is close to 5, and this is denominator. So we place this kind of formula. Here is larger divided by lower, and the result for that is the number, and we provide the single number of our tail probabilities. So what will be the probability that the number of claims will be 3 or more? And this is 4%. The single person will experience 3 insurance events in his or her life during the policy, the term of the policy, during 1 year, for example. So, and the probability that the 4 events will happen will have only a small number. And what is the probability of the probability that 4 events happen if before that 3 events happened. So conditional probability, right? So we divided this by that, and this is the number which we copied to the Moodle. Okay. So here, any questions? Okay. This is really not complicated. Then we can move on to modeling loss severity. Here is, I believe, week 13 already started. So we have, we have a collection of insurance policies, which consists of 2 types, and 25% of this and 75% of different types. So there are no singularity, and we need to consider both cases. So what actually we need to find? The loss amount per year follows the exponential with mean 200, and for a policy of type 2, the loss amount per year follows a Pareto distribution. So we have a mixture of those distributions. We have a mixture of those distributions. How can we deal with that? Okay, for a policy chosen at random from the entire collection of both types of policies, find the probability that the annual loss will be less than 100, find the average loss. Okay, so you will have to provide the single number, the average loss. So let's start with two variables, x1 and x2, and then find the how to say, the distribution function for those. And we know that the first policy type follows the exponential distribution with this mean value 200. So our in task 3, so the exponential distribution, the one we need to find, the fx, is 1 minus exponent to the power of to the power of what? To the power of just mean. Okay, mean 200. The annual loss will be less than 100. So the exponent should be minus 100 over 200. So this is the exponential distribution with mean 100. Okay. Then the Pareto distribution. The Pareto distribution, so here is x1 and fx2. The Pareto distribution should have 2 parameters, alpha equals 3 and theta equals 200. So it will be 1 minus, and again, the Pareto distribution is somewhat similar to exponential distribution with a little bit modification. So it will be 200 over the sum of 100 plus 200 and cubed. So this is the formula for Pareto distribution function. And we start with first, let's say fx1 is what we have already specified here. This value. Just change the brackets, exponent, and we don't need the the sign. So fx1 is actually 0.393. So our fx2 will be 200 over those. And fx2 is another probability cubed. Another probability. Too much. .7. So this is it. We have found the probability of the first event 39% and 70% of the second. Not the probability that the particular value will be less than that. So we have two types, then we need to sum them up with respected percentage. So 25% policies fx will be this 25% times the value times fx1 plus 75% times fx2. Okay, this is our overall value, 62%. fx, actually, this is the, when the loss is 100, so we'll have this probability that loss will be less than 100. 62% that loss will not exceed this number. Find the probability that the annual loss will be less than 100. So this is the value. And find the average loss. So average loss EX 0.25 times expected value of x1, where follows the exponential distribution with 200. So we multiply 200 plus 0.75 times for policy loss Pareto, for policy random, find probability EX2 0 times 100. So this is it. It should have EX value of 125. So in the here is not specified, but just follow the link. For example, find the find sum of those EX and FX, and you provide this number EX found. What? This is EX, this is FX. So you provide this single number as the response to this type of question. Okay. We have found that the loss will be, average loss will be 125. Average loss 125. And the probability that the loss will be less than 100 is 62.61. And that's it. So any questions here? The approximate probabilities will be the same. Probabilities will be the same. So this kind of question is a little bit complicated because we are using two distributions at the same time, and this kind of phenomenon is called the two-point mixture. So it is represented by subproportions of different modes. And there are always, if we talk about two distributions, there are always two parameters. These are called mixing parameters. From alpha is from 0 to 1, and the different parameter is 1 minus alpha. So when we add up, we have the full probability. So these two values, 75 and 25%, as in our task, should be what? 40-minute time limit. Ben, I will provide you the second link and you share with the line group. Okay. Okay. So we pause now. I'll create the new meeting and share with Ben. Okay.